Okay. Never seen that before.
Oh, I thought I didn't see it.
Yeah, some technical issue.
Oh.
Sorry about that. Yeah, so the practice exam is here, and other than that, yeah, and remote testing, I'll send that out after I teach my next class, so expect that. And other than that, let's go ahead and continue with equations of the quadratic type, which in other words, it's problems where we use U substitution. And we'll talk through strategies as such. So we did these two problems last time in class, and we're going to start up with problem 3 here. So it's just another example of, well, U substitution. And primarily the goal is to find some sort, with U substitution, the goal is to find some pattern and utilize this pattern by setting up a dummy variable, as we normally call it, which allows us to rewrite an equation as a quadratic. So here we can see that it would be really great if this was just x squared and this was just x. So then it would be x squared minus 12x plus 36. So it's got the quadratic form to it. It's just not a quadratic because it's not quite set up as such. So that's why we use U substitution. It's U substitution that allows us to convert. And generally, as I mentioned before, it's the middle term that normally gives us a pretty good idea of what the U is for the most part. So in this case, U would be 2x plus 4. So we could see that 2x plus 4 duplicates. So that's a pretty good indication that this would represent our U. And even better is that if we square both sides of this, we notice that U squared would precisely be the following term. So it works out perfectly. So that's just to confirm our choice. And now we can go ahead and make the substitution. So now it would be U squared minus 12U plus 36 is equal to 0.
Professor Brad, we cannot
That's
see your
after we
screen.
replace 2x plus 4 with U. So here's the rule. We applied it as such. I'm so sorry. I'm very sorry about that. Let me.
Just stop it, get out of it, and rejoin it maybe.
I just have to present. I never presented. I'm so sorry about that. Let me just start that over. I'm gonna get it right one of these mornings.
Nah,
Yeah.
probably not. Me either though.
Let me just start that over. That was complete lapse of brain power on my end. Okay, so U substitution, as I was mentioning, this will represent U. This will represent U squared because we are utilizing the implicit pattern here. So we see that 2x plus 4 is being duplicated. And additionally, I'm on page 40 of the notes for those of you at home. And so this would be the U substitution here. And the rule that we can apply is U is equal to 2x plus 4. And by applying this rule, that tells us that this part right here is going to be U. This part right here is going to be U squared by extension of this. So now it's U squared minus, there's a 12 out there, so 12U plus 36 is equal to 0. And from here, we can just factor. So the main reason why we do this is so we can get a quadratic, which we can factor. So U minus u minus, this is just standard factorization. So I think I see 9 and 4. No, wait, no, not 9 and 4. Let me try that again. 3 and 12, no.
6 and 6.
6 and 6, that sounds good to me. 6 and 6, cool. They multiply together to give us positive 36. They add together to give us negative 12, so that's pretty good. And from here, of course, this tells us that u minus 6 is equal to 0, really in both cases, so you get one answer. U is 6. But we're not done, because whenever we use u substitution, we're using this dummy variable of u, but we need to conclude with x's. If we don't have an x, then we're not done with the problem. So from here, we need to bring back our rule and we can plug in u is equal to 6 into this rule. This rule allows us to convert from u's to x's. This rule tells us how to do so. So we found that u was 6. We could subtract 4 on both sides to get 2. We just get that x is 1. So we get one answer. So hopefully this is okay so far. So embarrassing about the screen.
No, whatever you can. Don't be embarrassed.
Okay, well, let's move on to problem 4 here. So you might think problem 4, this one does not look like the other previous 3. I don't see any pattern offhand. I see nothing that we can work with, at least in terms of immediate u substitution, which is correct. There is nothing here that would immediately imply a u substitution. However, what we do have here is a radical equation. And so hopefully you remember what we do when we have radical equations. So I'll just rewrite the problem here. So with radical equations, if we isolate the radical, we can raise both sides by the root. So if this is a 4th root, we can raise both sides to the 4th power to get rid of the radical symbol. The 4th root and the 4th power would cancel. You get 8x squared minus 12 is equal to now x to the 4th. So all we did was just raise both sides to the 4th power. And that was only to get rid of the 4th root. So notice this is picking up on stuff from the previous section. And additionally, now we have a polynomial, which is just a collection of, x to the 4th, x to the 3rd, x to the 2nd, just a bunch of those. Generally, we want them on the same side. We want everything equal to 0. And you may notice this with previous problems we had. We already had the luxury of everything being equal to 0. Now we just have to facilitate it by moving everything over. So x to the 4th is already on the right, and we're going to move 8x squared over there, which will make it a negative 8x squared. And we're going to bump over the negative 12 and make that positive 12. So now we have that set equal to 0, which is just in general really helpful. That'll help us a lot moving forward. So now we get really a quartic equation. Quartic just means 4th power instead of 2nd power. And so this might perhaps look familiar. We did one just like this in problem 1. So notice that the steps to reach this were different, and in fact, required what we learned from the previous section. But now that we're here, we are going to treat it the exact same way we treated problem 1. And if you need a refresher about problem 1, then we used a U substitution where generally the middle term gives us a good idea as to what U is. Generally, that middle variable expression is a good indication for the U. So here, U is x squared. And by extension, U squared would be x to the 4th. So if anything, we have a good representation. What that means is now we can, so here's the rule, we'll use that later. So now x to the 4th becomes U squared minus 8U plus 12. So it allows us to break a larger non-quadratic equation down into a quadratic equation by using U substitution. And the convenient thing about that is we can just factor. U minus 6 and 2. They multiply together to give us positive 12, and they add together to give us negative 8. So we actually get 2 values from this. We get that U is 6, U is 2. But this isn't good enough. This isn't good enough because although we have U's, although we did a sequence of steps and found 2 answers, we have one more step to do. We have to convert those U's to X's. And that's when we have to bring back our rule. So here was the rule. So we bring back the rule, which tells us that U is equal to x squared. And so we found 2 U's. One of the U's was 6. So now 6 is equal to x squared. And the other one we found was 2. So 2 is equal to x squared. And we're going to solve for x in both cases. So it's just as simple as a square root. But remember, you have to do plus or minus. And these don't really simplify too nicely. The square root of 6 is not a nice number. You can put it in your calculator and you'll get a decimal. Generally, my math lab wants exact answers, so you would have to leave your answers as this. So really, you get 4 answers. Just like this. However, there's an issue.
Extraneous solutions, right?
What's that?
Is there extraneous solutions on this?
There are extraneous solutions. So you might notice, or hopefully you've noticed, that this falls under that domain of we have to check our answers, which might seem like a pain at first, except if you realize one thing. The 4th root, I'm going to write this up here. The 4th root of this expression here, that cannot be a negative number. The 4th root cannot output a negative number. Remember, we said that about the square root as well. Square root cannot output a negative number. Now, if this is equal to x, and we're saying that x is, say, if x is equal to, say, negative square root of 6, well, then now we're implying that the fourth root can output negative square root of 6. That's not good. In other words, the negative ones are going to be canceled out here because a fourth root cannot output a negative number. So that is the reason why we only get 2 answers from this. So before we had extra solutions, which ended up not working. So again, if one of these, if all of the solutions held true, then this would be one of the solutions. That doesn't make any sense. Negative sign, well, the negative number as an output does not equate to a fourth root. Same with the negative square root of 2. That's why we get rid of the negative ones here. So we only get 2 answers here, the square root of 6 and the square root of 2. Does anyone have anything to ask? If not, let's go ahead and move down to problem 5. So problem 5 here, this one may seem tricky. I do think it is a little tricky. There's actually 2 ways you can go about this problem. And depending on which way you do it, it might be based off of your preference. So the first way I see is you can factor out an x from both terms, or you can apply the u substitution directly. Both of them are not natural first steps in relation to how we're going to be doing all of these problems. So it's better I talk about it now. I think the easiest way to go about this problem is to first factor out an x. So notice when I factor out x from x, we're left with 1. If you distribute that back in, you should be able to see that. And by distributing the x out of 4x square root of x, we just took the x out. And one reason why I suggest doing it this way is because whenever you have a product of 2 things equal to 0, well, that's factoring. And why is factoring so nice? It's because we can split up each factor equal to 0 on its own. Just like this. In other words, you don't have to use u substitution for this problem. I just think this method's a lot easier because if you already notice, one of them's already solved for us. This one's already solved for us. So we already have half of the answers right there. And then the other half, we just need to figure out how to solve for x here. But what we can go ahead and do is, well, we can add 4 square root of x on both sides. Or you could subtract 1, it doesn't matter. The negative signs would cancel anyways. And we can also, we're trying to get x by itself. We only have 1 x, so we can divide both sides by 4. And then all we have to do is square both sides. So 1/4 squared is going to be 1/16. And so we get two answers. So I noticed this problem in the homework followed a slightly different trend than the other problems. So let's make sure you can recreate these steps on your homework. If you did want to consider what U substitution would be in this problem, U would end up being the square root of X in this problem over here. And then you would have, I'm not going to work it out, but you would have U squared minus 4U squared times U is equal to 0. So a little different, but that's how U substitution would have been applied, which may not be as natural in comparison to the other problems which we work on. Okay, so from here, we'll move on to problem 6, where I think there is a, if anything, a pretty discernible pattern here. I'm seeing x squared plus 24x repeat. So we're going to utilize that repetition. And in fact, as I mentioned, normally the middle term gives you an idea of what the substitution would be. So this one, so in previous semesters teaching this class, what some people normally identify U to be is x squared plus 24x, like this. This would not work out as it does not account for the square root here. You would end up having U plus the square root of U, and that's not really a quadratic. We need something that takes care of the square root as well. So that's why I'm also going to throw in the square root as part of the U. So I'm going to throw in the square root as part of the U, and this actually makes sense because if we were to square both sides, well, what's the square root, or what's the square of a square root? Well, they cancel out. And notice you get exactly the term over here on the left. So it works out perfectly. One extends to the other quite naturally. And from here, we can apply the U substitution. So that would be U squared plus really U is equal to 30. Because there's no other numbers that, other than 30, that were left out of the substitutions that we applied. And we can go ahead and bump the 30 over. Just like that. So that way we can factor this. So we'll have a U plus and a U minus, probably 6 and 5, seems about right. So we get -6 from this one and +5 from this one. But again, u's are not good enough. We need to go back to x's. And so that means we need to bring back our rule. So the rule was u is equal to the square root of x squared plus 24x, which means we'll have two different cases to solve for. So let's start off with the first one. So we'll call this one the first one. So the first u we found was u is equal to -6. So let's go ahead and plug that in for u. So -6 is equal to the square root x squared plus 24x. So this is when u is -6, and we'll talk about u is 5 in a bit. But I think I already know the answer for this first solution here. Well, here we have a square root. Here it is outputting a negative. That's not good. That can't happen. Square roots cannot output a negative. So this cannot happen. And so that means this whole value of u is completely tossed. If you didn't see this and you worked out the problem anyways, this means you would have to check your answers, and you would find that the two answers that you got from that part would not work. So that's why it's important that you notice this now, because now we just went ahead and got rid of the extra solutions. And then for the second solution, this one will be fine. So u is equal to 5. That'll be the second one. So now we have 5 is equal to the square root of x squared plus 24x. And 5 is positive, so that means we can solve this as normal. So we can square both sides. In fact, let me go ahead and do this. So we were here. Squaring both sides would give us 25 is equal to x squared plus 24x. And then that gives us 0 is equal to x squared plus 24x minus 25, which is something, so it's a quadratic within a quadratic. So that means we have to factor this. So this will be x plus 25, x minus 1. And so we get that x is -25 and +1. And we do not need to check these answers, as we got rid of the extra solutions up for the extra u that we found. Does anyone have any questions about this either problem before we move on? So the -25, was, of course, 5 squared was 25, and then we booted that over to this side. So they can all be on the same side and then equal to 0. And from there, we can factor as we normally would. So hopefully that answers your question, Molly. So I'll scroll down a little bit here. for those of you still writing. And let's go ahead and look at problem 7 here. So it might be cut off. Let me go ahead and rewrite it as well. So here we will have another U substitution, naturally. And so our U substitution in this case, generally, as I mentioned, the middle term gives us a good idea about that. This will, in fact, be U. And for those of you interested, the reason why this extends so nicely so that's why it extends nicely. We get, by squaring both sides, we get x to the 1/2, which is the variable expression at the very beginning. So we have u and u squared, and we can go ahead and plug those in accordingly. That's 6u squared minus 9u plus 2 is equal to 0. So generally, it'll work out nicely like that for the majority of the problems, that whatever you pick for u, the other one's probably going to be u squared. So and from here, we can go ahead and factor. Now, this one is not the, I suppose, since there's a 6 in the front, we'll have to think about which factorization method we use. Here we would have to use, if we try to factor it directly, we would use the AC method. If that doesn't work, we'd have to use the quadratic formula. Happen to know the AC method's not going to work. Let's go ahead and run into that issue ourselves. So if we use the AC method, that'd be 6 times 2 is 2, which is 12. So it's two numbers that multiply to 12 and add to give us -9. So that would have to be -6 and -2, or -12 and -1, or -3, -4. And none of those would work. None of those add together to give us -9. So in other words, this does not factor, which means we have to use the quadratic formula. So the AC method doesn't work. Doesn't factor, use quadratic formula. And remember, that means that A is 6, B is -9, and C is 2. And so what that tells us is that U, not X, but U in this case, is equal to minus -9 plus minus square root -9 squared minus 4 times 6 times 2. All of this divided by 2 times 6. So let's go ahead and clean this up a little bit. It's 9 plus minus the square root of 81 minus 2448.
I got 33.
33?
That's what I got.
Cool. And then over 12. And this, and the square root of 33 cannot be broken down anymore. 33 is, well, it's not prime, but if you do the factor tree, you won't find any pairs, as we mentioned before. You just get 11 and 3. So, in other words, You might think, is this really the answer? Well, it's the answer for now. It's not the final answer, though. That's the answer for you, but we're not done yet because we need to go back to x's. So now we can go ahead and bring our rule back. So we can get x values. So now this says that since we know that u is x raised to the 1/4, and we know that u is this expression here, we now have that u, which we found is this whole fraction. Yes, this whole fraction with the plus or minus and the square root, that all carries along. We know that this is now equal to x to the 1/4. And how do you get rid of a 1/4? Well, hopefully you remember that x to the 1/4 is equal to the 4th root of x. So how would you get rid of a 4th root? You would raise both sides to the 4th power. And that's why the final answer you get is that whole expression to the 4th power. And this is exactly the answer. Well, this is the answer that you would put in MyMathLab. It's a pretty notorious problem, but yes, that is in fact, there is a plus or minus symbol in MyMathLab as well that you can utilize. But this is the answer that you would put in. So does anyone have any questions about this one? If not, just one more to do for this section. So number 8 here, we have these negative exponents. And it does have a quadratic feel to it. And it would be great if we could just ignore those negatives. Because if we did, then all we would have is a simple quadratic. But that's not the initial case, so that's why we have to use u substitution to facilitate this. So the u substitution, generally the middle variable gives us a good idea as to what the u substitution will be. The x to the -1 is u. And by squaring both sides, that would take care of x to the -2 as well. So this tells us that we would get u squared minus 5u plus 6 is equal to 0 after we apply the u substitution. And the good thing about this is we can go ahead and factor. So u minus 6 and, actually no, I take that back. 3 and 2. -3 times -2 is +6, and their sum is -5. Cool. Which means we get 2 values for u. We get +3 and +2. From here, we can go ahead and bring our rule back because u's are not good enough. We need x's. So one of the u's we found was 3. So now 3 is equal to x to the negative 1. And the other one we found was 2. Now the question is, how do you get rid of a negative 1 power? So you get rid of a negative 1 power, so we knew how to get rid of a 1/2 power by squaring, a 1/4 power by taking the 4th root. We get rid of a negative 1 power by taking another negative 1 power. So in essence, we can get x by itself if we raise the other side by negative 1. This makes sense because you raise a negative 1 power to negative 1, then it ends up simplifying as negative 1 times negative 1, and that's just positive 1. And so what is this? It just means 1 over 3. The negative 1 exponent just means flip. That's all it means, just flip. So what you're doing is you're getting x by itself by flipping the other side. That's what happens here. So here, x would be 2 to the negative 1. The negative 1 means you just flip. So that'd be 1/2. So that's all it's saying. Negative 1 as an exponent generally just means you're going to be flipping stuff. So to get x by itself, you'll flip the other side. I think that's the easiest way to explain it. So we get 2 answers here. 1 over 3 and 1 over 2. Does anyone have any questions about this? If not, that concludes this section of material. And it would be very good if I could get done with the next section in today's class. So let's go ahead and do that. I'll go ahead and leave this up here as I talk about this next section a little bit. So that last section, we were talking about the substitution method, which is, in my opinion, the hardest section going into the midterm. This next section, though, it's more straightforward. It kind of generalizes one of the things we use in the AC method, which is called factoring by grouping. That's what this new section, this factoring section is all about. It's just a factor by grouping section. So generally, this one is pretty well received. The homework for this one shouldn't take you too long. Let's kind of go ahead and talk through what these problems would entail. Starting with problem 1 down here. So there's a few questions on this homework that asks you to factor out the greatest common factor, something like that. And so there's not even anything to solve here. It doesn't say solve, it just says factor. So in problem 1, really they give it to us. They give us the common factor here, the common x plus 9s. So if you remember from the AC method, whenever you figure out what the 2 numbers are, you end up factoring by grouping. So this is the same idea. We're factoring out the x plus 9 from both terms. So really what we're doing is we're taking out the x plus 9s, and then what's left over is, well, what do I see left? There's a 5. See a plus 4a. And that's the answer. That's it. It's one step. That's factoring by grouping ultimately. They just take it a step further for us. And next part is very similar. They tell us the common factor already. So we would factor out that 2x to the 8 plus 9. Once we factor that out, what's left over? Well, 3x plus 4. Again, that's it. That's all you have to do for those problems. So hopefully, so far, so good. Now, generally, factoring by grouping is normally something you do when you have 4 terms. You have 4 terms. So in example 2 here, notice you have 1, 2, 3, 4 terms. So generally, this is a process that you would do in that situation. You have 4 terms, you would factor by grouping. So in this problem here, your thought process should be, all right, I count 1, 2, 3, 4 terms. That means I should factor by grouping. What am I grouping? Well, I'll group the first 2 things together and the next 2 things together. This is just like the AC method. And then with the first 2, you think about what's everything they have in common. So with the first 2 here, what is everything they have in common? They both seem to have an x in common. That's all I see. So they both have an x in common. And then once I take out an x, it seems like we're left with 2x plus 3y. Because I took out one x, and then I took out that x from that term. All right, so do the same thing for the next one. We group these 2 together. So what do they both have in common? They seem to both have a 4. They both have a 4 in common because 4 goes into 8 and 4 goes into 12. So it's not a variable that they have in common, it's a number. So we're factoring out plus 4. So we're dividing out 4 from 8, that's 2x plus 3y. And this is good because we want what's left over to be the exact same. That is not a coincidence. We want what's left over to be the exact same. And then it just reduces to a problem that we had in example 1 up here. So notice it's the exact same problem now as if this was an example 1 problem. So the common term is 2x plus 3y. And what's left over? X plus 4. That's the answer. So this section is a glorified factor by grouping section. So if you're good with the AC method, this should be fine. So hopefully the lack of steps is good for now. So I'll go ahead and move on to example 3, which takes it a step further. And really the step further is now we're going to solve, which means now we have equal to signs, and solving means we're going to find a value for x. So for example 3, we'll go ahead and start off with the first problem here. And with this problem, well, it's definitely good to set everything equal to 0. Set the polynomial here equal to 0. We need to first go ahead and subtract 2x squared on both sides. And the reason why is just so we can set, so we're moving 2x squared to the other side. Just like that. Just so we can set everything equal to 0. Now this problem might seem out of place because we don't really need to factor by grouping unless we have 4 terms. In this problem, we only have 2, which means we could just factor, just straight up factor. There's no grouping involved with this problem. And that helps because both terms seem to have x squared in common. So that's all we have to factor out. They both have an x squared in common. We factor out x squared from 9x to the third. We seem to be left with 9x. If we factor out x squared from negative 2x squared, it's minus 2. So this problem doesn't even require grouping. That only, we do grouping when there's 4 terms, but there's only 2. But in general, factoring is nice because now we have a product of stuff equal to 0, which means we can start breaking this up. So we get x squared is equal to 0. I'll move the other one up here. And 9x minus 2 is equal to 0. This one over here is pretty quick to solve. It's 2 divided by 9. You add 2 on both sides, divide by 9. Over here, it's just a matter of taking the square root of both sides, but the square root of 0 is just 0. Or if you want me to work it out as such, and you do have plus or minus technically, but plus or minus 0 is still just 0. So you get 2 answers. Problem 2 will resort to factoring by grouping because there are 4 terms. So there's 1, 2, 3, 4 terms, which means we would use grouping. So grouping. And so what are we grouping? Grouping the first 2 and the next 2. So with the first 2, what all do they have in common? Seems to be x squared. They both seem to have x squared in common. So we have x to the third, and we took away 2 of the x's. Now we just have x. And 4x squared, well, we took out x squared, so it's just minus 4. And if anything, we know what the inside of the next one should look like. So if anything, we should anticipate that. So for the next 2, they seem to have a, well, if you factor out a 16, if you were just to factor out a 16, in fact, I'll write this in red, so this isn't correct on its own. If you factor out just a 16, then you would be left with negative x plus 4. And notice that's off. It's not the same as the x minus 4. It's off by a sign. So to make them match, we have to factor out negative 16. So instead, we have to factor out negative 16, which will then give us x minus 4. Because factoring out the negative will flip the signs. So negative 16x, taking out negative 16 just gives us positive x. Taking negative 16 out of positive 64 will give us negative 4. And now we have the pattern that we sought. And then it reduces down to previous problems. That's what we factor out, the common x minus 4. So what are we left with? X squared minus 16. But this is not the final answer, because x squared minus 16 can be factored even further. Or rather, remember, all of this is still equal to 0. So what this tells us is that, well, if anything, that tells us that x minus 4 is equal to 0, and then x squared minus 16 is equal to 0. So if anything, we get that x is 4. We get x is equal to 4 from the first one. The second one, you can either use a difference of squares or just solve for x. So we add 16 on both sides. We can take the square root of both sides. And so we get that x is plus or minus 4. So really, we only get 2 answers here. Because one of the answers duplicates. We get 4 twice, which is okay. Does anyone have any questions about either of those two? If not, let's look at problems 3 and 4. So for problem 3, there are not 4 terms, so we do not use grouping. Instead, for problem 3, you may notice that they all have, every term has something in common with another term. They all have an x in common. So we do not need to use grouping here. They all have an x in common, which means we can factor out the x. Now we get x squared minus 16x plus 60 is equal to 0. So that's after we factored out an x from every single term. And what's great about factoring is this means we can split up. So now x is equal to 0. X squared minus 16x plus 60 is equal to 0. So one of these solves itself. The other one, we factor it. This one's 6 and 10. And so we get 3 answers, but that would be it. So we get 3 answers here. So that one's not really grouping, more so as just factoring in general. And we can go ahead and move on to problem 4 here. So I'll just rewrite it. It's a little cut off there. So if anything, we want all of this equal to 0, as it'll be helpful with factoring later on. So I'm going to move the 2x, or the x squared rather, over. So minus x squared. And then minus 18x and plus 9 is equal to 0. So I moved everything over to the left, which changed those signs. So we have 4 terms equal to 0. We can go ahead and use grouping. What are we grouping? We are grouping the first 2 terms and the last 2 terms. And we're just going to see what they have in common. The first 2 terms both have x squared in common. So once we factor out an x squared, we are left with 2x minus 1. And then for the next 2 terms, we seem to have I'm going to factor out a negative 9. The reason why I factor out a negative 9 is so I can get a positive 2x here and a minus 1 here, so that these 2 will match, intentionally match. So the recurring term, or the recurrent expression, is 2x minus 1. And what is left over? X squared minus 9. We are solving this. So now that we have it factored, go ahead and solve each one individually. Well, that's not really going to be helpful for in-class people. So if anything, one of them is 2x minus 1 is equal to 0, which we can solve pretty quickly as 1/2. And then for the other one, there we go. So for the other one, being this one, x squared minus 9 is equal to 0. X squared is equal to 9. And then x is equal to plus or minus the square root of 9, which is equal to plus or minus 3. So really we get 3 answers here. Does anyone have any questions? So the reason why I wanted to finish all of this, so that's everything up to the midterm. So this is what I wanted to do. I can move the homework for substitution method to Wednesday. The reason why is so I can make Wednesday a homework review session. So no lecturing on Wednesday. I'm just going to do a homework review session. You can come to it if you want to. You don't have to. I'd rather you show up and have some homework that you've worked out and tell me what you're struggling with. And I work out questions going from there. Or if you're doing fine with the homework and don't need my help, then you don't have to show up or do anything. And then on Friday, I'll have the midterm review. So that's how these next 2 class sessions are going to play out. I'm sending out, so as I mentioned, I'm sending out an update to how to sign up for the midterm remotely. I have another class after this one, so after that class, I'll send out that email. It'll just be step-by-step what you have to do. And besides for that, I think that is all I have. So if you have any questions, I'll stick around. We have a few minutes, left, but if you don't have any questions, you're good to leave for the day. That's all I have. Yes, so if you're taking the midterm on campus, you will show up at, depending on whether you take whether you're in group A or group B, I'll mention that in the email as well. But yeah, you'll show up for that designated time that I email to you, and I'll just emphasize what your time is. To the test, calculator and pencil.
About scratch paper.
They'll provide it. Because if you wrote all the answers on the scratch paper.
So, is it gonna be like
Formulas. The formulas.
Sure, yeah.
Okay. I have a question. This is Caitlin, by the way.